Hello everyone, my name is Dr. Chow Song. I'm the head of school for the School of Life and Physical Sciences. Today I'm going to give you a quick introduction about the school, and then that'll be followed by a talk by my colleague Dr. Seah, who's going to talk about empowering 21st century life sciences. Just give me a moment here. We have an issue with the clicker. Okay. Right, so PSB Academy has got 9 partners from the UK, Australia, and New Zealand. We have at any one time 12,000 students on campus, and we run 70 full-time and part-time courses. There are 37% of our students are in STEM courses, and that's where our life science school is runs our program. Okay, and there are 300. We have about 300 full-time and associate lecturers, and we have 4 campuses across Asia. Now, in Singapore, we have 2 campuses. The city campus is in Marina Square, and the STEM campus, where our laboratories are situated, are in Toa Payoh. Now, these are the head of school of the 5 schools that are in PSB Academy. And we are, of course, the School of Life and Physical Sciences. Now, to ensure academic excellence in our curriculum, we have an academic board that governs over all academic matters. And this academic board is chaired by Prof. Siren from the NUS. The academic board looks into matters related to things like curriculum development all the way to exam processes. To ensure that our curriculum are industry relevant, we do have a science industry advisory panel as well, and we have distinguished members from the research institutions and all the way to manufacturing facilities in the pharmaceutical sector. Now, for the School of Life and Physical Sciences, we run 2 major programs. One is in the life science area, and that is in partnership with La Trobe University, where we run 4 programs with them. And the other area is in sports science, which we partner Edinburgh Napier University. Okay. For life science program, we run programs from the foundation diploma level all the way to the undergraduate level. So students who are not able to enter first year into La Trobe University programs directly can actually join us through the foundation diploma program. And after you complete the foundation diploma, you're able to progress into the first year of the La Trobe programs. Okay. Now, studying science is a very challenging curriculum, right? Science is extremely challenging, but it's also very rewarding when you study sciences. Now, it not only trains you in terms of academic content, but it also trains you to think critically. It trains you to problem solve, and it trains you in analytical thinking. And that is what employers in the industry are looking for. Okay, so if you study science, you'll be very much sought after by the industry, and not just in the science sector. You could be looking at banking sector and so on, and you will see that the employers in this sector is also sought after science graduate very, very much. Okay, so La Trobe University partners with us in 4 programs as I mentioned earlier, and one of the key things about PSB Academy is that we have a very well-equipped state-of-the-art laboratory that supports these 4 programs. And it is almost impossible to do life science programs without those laboratory equipments and facilities. And that is what we pride ourselves in at PSB Academy. Okay, so I'll now pass on the talk to my colleague, Dr. Seah, who will be talking on empowering 21st century life sciences. Thank you.
Okay, so good afternoon, everyone. Welcome on board for this virtual open house. So my name is Seng. I'm an instructor in this school. So I'm actually teaching particularly the biotechnology and the biomedical sciences. So our talk today is to actually share with you some aspects about the recent changes So I will name my talk as a course of discovery and inquiry. And that's important because in life sciences, we'll find that we want to embark on a journey of discovery. Science is changing every day. New discoveries are being made, and that we are always adapting to world changes. So let me begin my talk, and I hope that the next half an hour or so will give you some perspective about science in general, and hope that it ignites your interest and passion in science. So my key topic will cover these 5 areas. So the first one will be looking at infectious disease. So I'm going to later show a list of infectious disease that has been around for the past century, and that what have we done, for instance, as a community, as a scientific community, to actually tackle this disease. The second aspect will be looking into technological advances. So I'm going to look at, for instance, what are the key discoveries in terms of biomedical sciences, new technologies that allows work, that allow processes, that allows, for instance, the ability to study science to be actually much more streamlined, and then we can then feed it into the global context. The third part will be addressing generic issues that affects the world in general. We know that the world is experiencing an aging crisis because people are getting more healthy, people are living longer, and hence we are going to be reaching a situation where we have to develop the adequate resources to actually care for our elderly as well as our seniors. So this will then bring on to the more global macro aspect, which is the climate changes. So recently you may hear in the news that climate changes are very important to us because that will affect, for instance, weather patterns and so on. And more importantly, a week ago, they actually mentioned that there is a new change of the ozone layer, which has actually recovered significantly in the Antarctica. So I will structure my talk from going from the small to the bigger picture, and hopefully that will then bring us back into the global perspective. So at the last point, then I will talk about some of the programs that we have to support this course of inquiry and discovery. So with that, I'll bring you to the first slide. So in this slide, you'll find that listed on here are the major timelines of the various diseases that has occurred for the past century. Some of the key ones includes the Spanish flu, which is about 100 years ago. So at the time, it kills millions of people. How are we able to, as a society, actually go over it and then recover from it? And in the 1950s, we find that there is another urgent disease, which is polio, affects children, teenagers. And then how does the world adapt and go over it in terms of developing a vaccine? With the development of polio vaccine, for instance, you find that the number of deaths has dropped significantly, and that is now one of the mandated vaccines in endemic areas. I find that that is something that society, science can work together to actually put up responses towards infectious disease. At this point in time, your concern will be the current situation of COVID-19, which I listed as the last point. So you find that it is actually an increasing and emerging global issue. WHO, CDC has actually launched responses towards it. So how are we able to, as a budding science community, training new scientists, healthcare workers, to actually together help to cope with this problem? So in terms of infectious disease, what has Singapore done? Here in the slide, we have actually showed 2 recent articles. One, which is published in Today, where a world ranking survey has actually put Singapore as a number 2 in terms of the responses for healthcare outcomes, and that we have actually been very proud that our resident hospital, Singapore General Hospital, the oldest in Singapore, has actually beat some of the top hospitals in the world ranking. What these actually enforce is that our healthcare system is basically very professional in terms of dealing with the ongoing diseases, advances in treatments, as well as to actually invest a lot of research back into basically understanding more about medical trends, medical practices, and of course, investing in good medical infrastructure. What this actually brings forward is then, in terms of a national initiative, we are able to actually put plans, master plans. This allows it to stretch beyond 5 years, 10 years. So one of them is listed in this slide, which is the master plan for 2020 and beyond. So in it, what is actually critical is that the government has actually put up plans to increase the number of healthcare institutions. And on the map there, you can see that various healthcare institutions, including, for instance, new hospitals, community hospitals, and supportive, for instance, care facilities are being built up. So this is going to reinforce the need for newly trained, for instance, professionals, as well as graduates in the healthcare sector. And I believe with the current COVID-19 situation, there will be an increased demand to ensure that every nation has the ability to have the relevant professionals, graduates to support this area. So this is basically for national sustenance for the long run. So to support that, I will bring you to the next slide, which actually highlights the research and development footprint that is spearheaded at the national level. So here is the Research Innovative Enterprise 2020 plan. You'll find that amongst, for instance, the focus area, which is split into various groups, including advanced manufacturing. There are also other groups, for instance, like manpower, academic research. I will want to bring your attention to the second point, which is about 4 billion of funds have actually been set aside for the healthcare and the biomedical sciences. So why is there such an important focus? And it is around 21% of all the funds that is ultimately allocated across the various research teams and pillars that is going to support Singapore in the next 5 years, 10 years. So this means that there is a lot of potential for healthcare in the sector in terms of technology advances, in terms of the platforms, as well as for training to actually be improved gradually over the years. So what you can expect as a result of that, after taking a biomedical course, for instance, you have then acquired the graduate capacities to actually then excel and to contribute back to Singapore. So to bring you into the next part, I'm going to now talk on the second point, which is the technological advances. And with technology advances, we are going to look at some of the new research discovery. At this slide, what we have seen here is some of the research technologies that have been around since last year. So you may have heard about gene editing. Gene editing started with CRISPR, where people are able to use this technique to actually modify parts of a gene with intended desired effects to be actually built in. So this means that we can actually do genetic editing in a highly precise manner. So in simple, it is basically using copy and paste, and we paste the corrected, for instance, healthy version of a gene into the individual or the patient, and then we are able to then, in the process, remove the unhealthy or the mutated copy. So that will have definitely implications in the long run, whether in terms of cancer treatments, helping with genetic diseases and so on. But at the micro picture, we are going to see how technological advances have actually led to some of the improvements. CRISPR, as an idea, started in about 2016, gradually improved over the years. Last year, a major breakthrough has been actually achieved. So what this major breakthrough is in the form of a base editor. So you find that instead of just having the capacity to edit a section of a gene, now we can edit specific bases. So this means that there is much more versatility, much more specificity in this system. So you may be thinking how all these upcoming trends may relate, for instance, to the pursuit of a biomedical science education. So what this actually brings about in you is to train you with the critical thinking skills, to arm you with the core research skills so that you are able to play as a key player or a key contributor in the ever-growing research and discovery journey after you have, for instance, graduated. So this means that with all the training, most likely you are able to facilitate, for instance, in the core discovery, working in research lab, and most likely whatever you are going to discover in the next 5 years, 10 years, may actually change the direction, not just for us, but maybe for humanity. So on this slide, I'm going to just quickly share with you what this significant step in terms of the gene editing has basically taken place. What it does here is base editing. It is a recently developed and improved technique with 3 parts of a component. Think of it as just 3 processes. We are able to actually do a specific nucleotide change. So there are some problems, which is in terms of the problem with DNA stability. And I believe that in the next few years, scientists is going to improve on these processes and makes, for instance, this entire procedure much more specific and hence much more useful for the long run. So what we can expect from it then is going on to version number 2 of the gene editing process. So on this slide, I'm not going to tell you more about the technical details, but how it actually works is it allows you, number 1, to have the spatial control, meaning that it is able to recognize the region quite accurately and then allow you to perform processes like taking away a stretch of sequence, deleting a gene, for instance, inserting a new one in replacement, or even substituting it. So for instance, what you have may be in a genetic disease, you may be a carrier for a disease, meaning that you may have 1 copy of a gene that is mutated or 2 copies of a gene that is mutated in your chromosome because we have 2 sets of the same set of genes. So using this technique, it allows us to actually help not just people who are genetically, for instance, predisposed to a disease, but also carriers for the disease as well. In terms of how it works, it is able to go highly specifically to modify the key nucleotides that is concerned, and it's actually working well in mitotic cells. This means that it can be used to correct for gene mutations in cancerous growth tumors and so on, and this may bring about new therapies. So I will then bring you to the next aspect, which is another discovery that is recent, because the key idea here is they have actually surveyed all the bacterial groups within our intestinal tract. And from there, they found out that there is one specific bacteria that has the ability to modify the sugar residues on the surface of the proteins, which is on the cell. So what it does here is by applying it into the hematological aspect, you can actually change, for instance, a blood typing. So you may be thinking, yes, it's just a sugar change. How does it relate to the big picture? So in terms of these gut bacterial enzymes, they are highly efficient. By doing these type of antigenic changes, they actually allow us to solve one pertinent issue in the world, which is the lack of people actually actively donating blood. And we know the hospitals needs a lot of volunteers to actually donate blood for transfusion purposes, for surgical purposes. So are we able to use this to modify, for instance, most of the other blood groups to then allow us to be able to be more flexible in using them wherever it needs to? Of course, this doesn't solve the main problem of not having enough volunteers to donate blood, but it allows for some flexibility. At least we can convert most of the blood groups to a pseudo-O group that can then be helped to actually address any of the transfusion concerns for the patient. So as we have talked about some of these key discovery, this slide integrates it into the bigger picture. What we are trying to say here is the impact of biotechnology is about sustainability. So biotechnology covers all areas, not just in new technologies. It also covers things like crop sustenance, improving, for instance, crop yield, resistance tolerance. They also allow us to actually harness the existing biotechnological research in terms of how we can relate them to the main problem of the world, which is how to feed the ever-growing population. So this means that we have to address, number 1, food security. Number 2, having crop resistance property in the, for instance, crops that we are going to use to actually feed ourselves. So as part of the critical role, you can find that there is actually a large amount of effort, resources, land area actually put aside just to increase the crop yield. And that is critical because we need to incorporate new advances in biotechnology to allow us to generate more superior crops. And these will be most likely able to address food security concerns in the next 5 years to 10 years as population of the world continues to increase. So I'm going to now talk about some other aspects, much more on a global basis, how it actually helps us with the current situation where in the view of ongoing disease pandemic, testing is important, diagnosis is important. I believe that in the recent past weeks, you may hear that most of the countries are actually actively purchasing or basically manufacturing all those testing and diagnostic kits. So what we can see in this picture here is molecular diagnostic. Why is it important? And why are we looking at molecular diagnostic? Because we want it to be fast, efficient. Having the data, having the analysis done more efficiently allows us to have more time to actually respond. So you may heard that it is important that if testing of a virus, instead of taking 2 days, can be reduced to a few hours or even to less than an hour, it actually allows us to adapt to the patient and then to recommend all the treatments that is necessary and to inform the patient and the doctor about the best responses that can be put up. So intervention strategies often is linked to the speed of diagnosis that can be actually made available by these molecular diagnostic kits. So when we talk about molecular diagnostic kits, it is not just testing for a virus. It can also be used to test for, let's say, diseases. So one of the items on this slide that highlights this recent trend is that there is an organ-on-chip development where we are able to actually do testing of all the organisms in terms of the various genes, responsiveness to drugs, groups of genes that are changed, for instance, at a large scale. No longer are we looking at testing one gene at one time. We are able to actually scale it up for simultaneous or what we call parallel testing of hundreds or thousands or even the entire genome of the organism in something as small as a chip, which is about half the size of your transport card. So at this point in time, we may also be thinking, yes, viruses, diseases, yes, but what happens if things are new, things are going to be rejuvenated, and then things that is long forgone, for instance, polio, smallpox, what happens if any of these come back? So I'm going to just show you in this slide some of the recent approaches in terms of how they have discovered, for instance, in the glacier environment, where you find that viruses that is not seen before for millions, billions of years have now resurfaced. Why is it so? Because of global warming, the ice have basically gradually thawed. And this basically exposes a virus into a new environment, which is very distinct from where they are originally, for instance, proliferating millions of years ago. So example will be a Yara virus that is actually discovered recently with no known annotation done on its genome, meaning that scientists do not know what is actually within the genome, and it takes time to actually study. So how does this basically relate then to back to the big picture? Because if we have global warming, we are expecting all those hidden viruses, whether trapped in the bottom of the oceans, buried under the ground, or locked in ice, they may eventually come about, re-emerge, and then that will be something for us to eventually address. So in other words, based on the various slides I've talked about in terms of technology and so on, having the capacity, having the ability to do diagnosis, having all the biotechnological advances for us to cope with all these changes allows us to better cope with the future. What is not precedented, what may be upcoming, so that we can actually best adapt to all these situations in an ongoing fashion. So I'm going to now shift gear a bit to talk about population in terms of aging. And you'll find that in this article that is described, even in Singapore, and not just in Singapore, I think the entire world, including Japan and so on, it is always important to always revisit aging. Ideally, you find that people are actually living longer because of better nutrition, better healthcare system. So how are we able to then address such concern? So does science and technology play a key part? Yes, because if we can improve the healthcare, if we can improve, for instance, the in terms of the drugs and all this that is available for this group of patients that is elderly, they are most likely able to live even longer. And how are we able to then adjust to cope with them? So things that is important for us to focus on at the national level is, number one, people may be thinking, yes, the aging population may actually draw down resources, but is it really a key issue? Not really. if we are able to actually get healthy individuals, even at their senior ages, to still contribute to the economy in some way or another, definitely there is some room for them to be able to self-support themselves and as well as basically live life and enjoy the old times and then facilitate all this with time itself, okay? So I'm going to now move on to the next point, which is the aging crisis. So on this slide, you'll find that it's talking about the old age support and so on, particularly in terms of the resident population, constraints, the ratio, and so on. A few things that is important. Number one, it is always linked to a rising life expectancy because people are living longer, as what I've mentioned. It is also linked to adults that is going to delay having a child later on in their lives, so they may spend more time on building their careers and so on. And lastly, because of the declining childbirth rates, this may actually skew the ratio over, for instance, the working adults in terms of their support towards the elderly. So how are we going to actually address that? So in terms of this slide, what we can see here is there are more people in Singapore that appears to be actually staying single. A few things to note is that we find that the trend is of course going to hurt a little bit on the fertility rate. It is because that the newly educated, for instance, young adults actually are focusing on their career. Apart from that, it is also about the concept of balancing their work lives and so on. So how does this actually bring on to the big picture in terms of the effects? So to just sum up for the aging crisis, aging is something that we cannot, for instance, avoid. There is no immediate solution to it, but science is able to bring part of the solution, whether it is actually more drugs that is available, more treatments, more support, or even a better medical infrastructure to actually help to cope with aging in one way or another. So I've addressed aging as a global issue. Now I'm going to move on to a much more wider aspect, which is on climate change. So you may find that in the earlier part of last year, and for a few months, you may hear that there is actually an ongoing fire. There is actually in the South America continent, in Amazon forest, as well as in Australia. So the bushfires, for instance, as well as the fires in the Amazon actually has led to a lot of things. There is loss, property is lost, livelihoods, for instance, are affected, lifestyle, crops are destroyed, and of course, pollution may be indirectly triggered as a result of that. But do we see something in it? Yes, it is all potentially human triggered. Why is it so? Because of climate crisis, because of the changing weather patterns. The weather gets drier when it is supposed to be wetter in terms of the seasons, and there is some changes. Definitely, we have heard that in the past years and so on, the El Nino and the El Nina effects in terms of the ocean current, they do affect, for instance, all these weather patterns globally. And I believe that in the past few years, you also have heard that there is also increased, for instance, evidence in frequency of typhoons, cyclones, and tornadoes and so on. So all these are also part and parcel of the weather pattern. So on this note, in terms of climate change, what are we actually looking at and how can we help it? So on this diagram, you'll find that, yes, we can see that in terms of the glacier, it has over the past years, like 10, 20 years, actually the entire cap is gone. So what you're seeing here is, of course, it opens up new opportunities because there are, of course, ways that we are thinking about the Arctic and opening up for new shipping routes. Of course, that is one of the possible economic outcome. But generally, in terms of the climate change, it is going to then affect, for instance, like how we are able to see at the macro picture, including, for instance, like drying of water sources. And of course, that will affect the local farming, livestock rearing activities in this area. If people, let's say living in Bolivia, is actually going to be reliant on the water source for their daily activities. So at the macro picture, you'll find that, yes, we have things that is small. We have talked about research opportunities. We have talked about research advances. We have covered national issues, which is aging and so on. So back to the main picture. How does being trained in science help you to solve as well as to allow you prepare yourself better to contribute in this aspect With that, I'm going to now do a brief overview about our programs. Our programs are covered in 4 areas. They will train you in molecular biology. We also have programs that is in biomedical science, pharmaceutical sciences, and also in chemistry. So these are the core branches of science, and that what would you then learn in these programs? So in these programs, we are going to learn, for instance, critical thinking, and then adapting, for instance, all this information into a global citizen type of environment. How can you interrelate with issues that is happening in the world, which I've just described earlier? So how do you basically have a better awareness of this issue? How well are you positioned in terms of answering or contributing to some of the improvements towards these issues and their potential solutions? How are we seeing ourselves as a global player, as a science graduate, to actually address this issue? So you'll find that things that is critical in these programs that we have here is to train you to, firstly, be able to communicate, present well, and that we are emphasizing on teamwork. And this is important because we want you to actually be able to work in teams as an effective team player, and as well as to be a team leader in the years to come. So in terms of the other aspects, what PSB does offer as well is we have student club activities, we have enrichment activities, we have industrial visits, we have also a lot of free public lectures and so on that allows you to actually gain more awareness about what is happening outside of classroom activities. So we also have, for instance, resume and writing workshops that actually prepare our graduates for the world out there so that they are able to pitch themselves, and then this enhances significantly, for instance, the employability, and then allows them to immediately, after graduating from our course, contribute to the scientific community at large. So to talk about the career opportunities that is available in science, you'll find that science is a curriculum base that is really about inquiry and discovery. Because information is updated, new discoveries are formed, new discoveries are then going to be translated, and that you are going to see the outputs of what you are doing now, what is actually being done now, mainly in the years to come. It can be 1 year, 2 years, and it is one of the shortest, for instance, translational type of things, style of strategy that you can see that whatever has been discovered, immediately will put in clinical use. To give you an example, you may be aware that now most of the big pharmaceutical companies are either working alone or working in groups, in consortiums to actually work together to discover vaccines. So are they able to push out fast? Yes. Why is it so? Because they are able to build on the existing strong fundamentals as well as the science community that is available, to tap on them, to know about all these different diseases, all the different structures, and all these new reports about the viruses that is actually being published regularly. As of actually December, you'll find that in major publications, new information is being shared. And then scientists are actually working on it along with their industry counterparts, the pharmaceutical companies, to actually try to give a vaccine, hopefully to address this COVID situation so that our lives will be able to return to that pre-COVID as for last year. So you find that in this aspect, studying in terms of science brings you a lot of different concepts where, it'll bring you a little bit of perspective that is slightly different from other disciplines. It trains you to be very focused. It trains you to think as well as to analyze things in a critical fashion. You look at problems in an alternative angle, and it is important for us to actually use the ability of your scientific build-up, your scientific knowledge to actually progressively, not just increase your economic value in terms of working in a greater society, but potentially, we believe that every graduate is ready to play a key part in the world out there. So in terms of the careers that is potentially possible outside academia, you'll find that here is listed some of the key, for instance, jobs as well as career options that is available. We can actually work in the research environment, work in the healthcare environment. We can also administer projects, for instance, like pharmaceutical projects. There's also opportunities for data analysis where you're able to look at all the key discoveries, the trends, and so on. You can also be a medical writer, reporting, for instance, science-related news for the media and so on. So there's also opportunities for being a public relations officer, as well as playing a key part in the industrial sector, including like the processing and the manufacturing of drugs and all the therapeutical products. So here is just some of the key companies that we have that is involved in the biomedical sciences. Some of them are actually common names. So they have actually factories that is located in Biopolis as well as in the Tuas Biomedical Park. So we do have some of our graduates that is actually working in that perspective. And normally we believe that these are some of the good companies that will further strengthen, for instance, our ability to produce graduates that is basically recognized by all these companies, and they're playing a very key part. So in terms of the advanced standing offer, I will just quickly run through it. In terms of you having a prerequisite diploma from the polys, depending on the courses you are, you may be given advanced standing of up to 12 months exemption. So if you have a specific query, our admission team will be more than happy to take your emails and as well as a query. So what it means here is that with the advanced standing, we are recognizing the effort as well as the relevance of your poly curriculum, and La Troupes actually allows you to undertake some of these courses as exemption criteria so that you can actually complete your degree at an accelerated phase, and this will allow you to actually contribute to the healthcare industry at a much faster pace than others. So to sum up, we just want you to actually focus on the passion as well as the course in studying life science. So a few things to note is that science is always evolving. So trends are moving towards the public and medical healthcare, at least as of 2020. And we have shared with you the healthcare master plan, what Singapore as a government, as a national, as well as the community is looking forward in terms of providing the increased medical infrastructure. And this will be important for us to relate to what we have learned in science and then to apply them to ever-growing large-scale problems. COVID-19 is just one of the examples. It doesn't affect just one country. No country is spared. All countries are now interconnected, and it will be more interconnected in the years to come. So as last part of it, we are just actually trying to say that it is important that it allows you to actually pave the pathway towards critical science inquisition. So this basically sums up this short talk about the course of discovery and inquiry. So in summary, what we have seen here is it is important as you develop your passion for science to be actually very interested and involved in all the recent science development. We see ourselves as a student of science to actually be able to contribute to the bigger, for instance, community out there with all the scientific knowledge, and then allow us to be a global part in this sector. Okay, so thank you very much for your talk. I will now take questions from you all. Okay, so one of the questions that is on the screen is, what is the recommended pathway to become a doctor? So one of the pathway in Singapore is you can actually enter doctor in terms of a medical degree study at a bachelor's level that is basically offered by NTU and NUS at the moment. But for us, our course trains you to be biomedical ready. What it means here is that you are able to, after completing our course, be able to take on basically post-grad medical options. So Duke NUS, for instance, offers that. Most of the other universities worldwide also offers the doctor training or clinician training as a post-grad course. So we believe that our course will prepare you for the fundamentals that is suitable and then relevant so that you are able to cope with the demands of the aspects of medical studies in the future. So most of our graduates, for instance, right, are working in the healthcare sector as well as in the clinician's role in terms of whether they have support assistance and so on. So there is definitely an opportunity that the training is providing you strong enough focus to actually launch a potential clinician career for you. So at this moment, our bachelor's program prepare you for postgraduate medical options. And we have successful examples of students that actually went on to be vets, for instance, and also progress on to pursue postgraduate studies. Okay, so the second question that I have from you is, given the current COVID situation, right, what is the career outlook? So the first thing that we want to stress is all the industries appears to be slowing down. The healthcare industry is not. Being prepared for being a key player of the healthcare industry is part of our training. So meaning that if you are looking into the biomedical course, it will train you with the key fundamentals. And given that the master plan of the healthcare sector is increasing and it is actually stretching from 2020 to 2030, so we expect that the amount of hospitals, community-wise, as well as general hospitals, is going to increase. There is definitely a lot of opportunities for you to, after completing this course, to actually launch a successful career in the healthcare science. So with the current COVID situation, healthcare is definitely not affected. And in fact, we'll find that some of our students actually are from the healthcare sector, and they are actively learning key principles to reinforce their current knowledge while they are battling at the front of COVID-19 diseases in hospital. And I believe that they are able to be well positioned in place to actually take advantage of this recovery of the economy as well as healthcare sector after this COVID-19 wears down. Definitely healthcare sector is the way to go. So the next question that I have on the screen is, after the completion of the foundation in biomedical science, what career path is available? Earlier, I've mentioned that there are a few different directions that you can take. Either you look into the research sector, where you are going to actively involve in discovery of new information, leading yourself at the forefront of science, because most of what you discover at this point in time will be translatable to a drug or a therapeutic product within 3 years to 5 years, or even slightly along that time frame. So another area that the career may take is in terms of a healthcare sector, where you're going to then play a part in supporting, for instance, the elderly, supporting the sick and the patients who actually need your support. And that is not just at the front line, but there are also opportunities in the healthcare sector to actually work as a hospital administrator, working with databases back end, thinking about health policies, and then executing, for instance, some of the health initiatives that the government may announce in support of current ongoing situations, such as the COVID-19. And this will most likely bring you, in terms of your training, into perspective. You get to relate all the biomedical trends, all the fundamentals, back into the current situation where you are able to apply them to key policies that, upon implemented, will affect as well as to improve, for instance, the patient outlook for the sector. So there's also another career path, which is actually moving towards, for instance, slightly away from the norm, which is to become a teacher or to become, for instance, a medical writer. So you can actually be a medical journalist. You can actually share articles online, and you can also be part of, for instance, the editors of medical journals, for instance, and that will most likely also allow you to train and hone your skills in this aspect. So those are the various career options, but most of our students actually is moving on towards the research sector, because our training fundamentally prepares them to be critical in their thinking processes, and then this most likely will be the key route. The second most common route for our students is actually going back to the healthcare sector and continue to actually help, for instance, patients who need them most. And most likely they are able to stamp their footprint in effecting some of the changes when policies are being reviewed to actually help the population as a whole. Okay, with that, thank you very much for your time this afternoon, and we wish you a good day.